There's so much misunderstood about quantum physics, I thought I would start right with the foundation. Not that I understand everything, there's more that we don't know about quantum physics than that we do know. So, since recorded civilization, man has been trying to understand matter and energy. You know, Aristotle was the one that thought that he gave birth to the idea of the atom. He thought that all matter must be composed of some really, really, really tiny indivisible elements, which we later came to call atoms. But that's about as far as he could go. Over 2,000 years ago, there wasn't a lot of tools to observe anything like that with. But we've been probing into the depths of matter. Probing into the depths of matter. And really, it's at the subatomic world that gave birth to quantum physics. But it wasn't just through matter. The real moment, they call it a Euclidean moment, Eureka. The Eureka moment occurred with a chap named Albert Einstein. And he published a really famous equation, E equals mc squared. Energy equals mass times the speed of light squared. But what that meant was Einstein demonstrated empirically, mathematically, and through astute physics of way beyond genius proportions, that matter and energy have an equivalence. Really, there's only energy in the universe. Matter is just energy waiting to happen. That's what we do in the world of nuclear physics, but that's what happens in the cosmos all the time. Stars are born, they die, they collapse. Sometimes their collapse is significant enough that the gravitational pull forms a black hole, and they suck entire cosmos into them, galaxies, and spit out stars. When he equated energy and mass, a profound discovery was made that had us really have to re-examine everything that we knew about physics. How I've come to view energy, it's transformative. It's shape-shifting. It's like the ultimate Avenger. You know how Dr. Banner transforms himself into the Hulk? That's what energy does all the time. It's mutable, changeable. Energy is changing its shape, its form, its fit, its function within our bodies, all around us in the air, in plants, on our planet and our solar system, in the stars. Chemical energy gets converted to thermal energy and heat. Nuclear energy gets converted to atomic energy, to heat energy, to radiant energy, to gamma waves, cosmic waves, ultraviolet rays, visible rays. Shape-shifting energy. That's the universe we live in. There's nothing intrinsic. There's nothing intuitive about quantum physics. If you want to learn about the world of quantum physics, you have to be extremely comfortable living in a world of ambiguity. When I worked for that Fortune 500 company, there used to be one of the evaluation criteria on the performance evaluations was, how comfortable are you dealing with ambiguity? And if you were really comfortable, you got a good rating. And if you weren't comfortable, you got an area for improvement. I hated that damn question. I'm a scientist. Ambiguity, by definition, means to be uncertain, to be unable to differentiate between two alternative views. Well, what the hell am I getting paid for as a scientist if I can't do that? I hated that question. And later on, when I became a senior executive of that company, I was instrumental in abolishing that question. Ironically enough, looking back on it, you have to be comfortable in dealing with ambiguity in life, and certainly in the quantum world. Because in the quantum world, a particle could be in two different places at the same time. We've proven it. Doesn't get much more ambiguous than that. The speed of light is a constant, no matter what. If you're riding a light beam at the speed of light and you're approaching another light beam coming at you at the speed of light, you don't pass each other at twice the speed of light. The light beam coming at you is only traveling at the speed of light. How's that possible? That's pretty ambivalent. If you were to travel at the speed of light, time would stand still. Subatomic particles pop in and out of creation all the time. Right now, right in front of us. There's a lot to be learned about quantum physics, and I look forward to teaching, learning, and growing with you as we go on with this. Thanks for joining me. I'm going to ask you to ask yourself this question. What ambiguities exist in your life right now that you might just have to accept can't be resolved because that's the way they are?